Thank you again. I just forget to record the meeting. It's okay. Until now, we still refresh all the information. We already spoke about this information last time. Okay, I think this example, we already took this example. This variable, we mentioned that it's extern. This means it's a global. Even if you did not mention it's extern, it's already declared outside any function. Then it's extern or a global, and you can use it any place in the main function or in this function, or even in another file if your project have more than one file, like this example. This example, we have two files in our project. One file have a global variable. You can mention that it extern or without even using this extern keyword. It's same because it's outside. This means it's global or external. You can see we have here another file. In this file, we use a variable. This a variable comes from here. How compiler knows that it's come from here? Because we use this extern keyword. Here you have to see that we did not declare it's different than, let me open the compiler. Okay. We have these variables, A and B. It's external variables. And we have this function that in another file, we use this variable A in this function here. Let's just discuss few things here. What type of variables we have? Here we have two global or external variable. Also, we have C as global or external variable. I did not mention that it's integer, but when you use any variable like this and you give initial value, then the compiler will understand that you are defining a variable. But if you did not mention this initial value, here you have problem, compilation problem. Why? Because the compiler cannot understand this C, what it exactly. But if you mention like this, it's similar like if you identify integer C. From this initial value, the compiler will understand that this variable is integer, is an integer. Okay, here we call this function, which is in another file here. In this function, we mentioned that extern A. Extern A, this told the compiler that this variable A is a global variable. Then the compiler will look here. Okay, we have global variable A. Then it's okay. This is the same global variable. Then in the memory, it's like this. When you define, let me just clear the screen. When you define this two variables, then you will have in the memory variable A with initial value 1. This variable is the external variable or global variable. And then we have B also with initial value 2. Also, it's external variable. Now we declare the function and start the main print f. Then we are calling this function, which is in another file. This one file, this another file. Of course, to connect two files, you need to include the file. Okay. Later we will speak about including file and when your project have more than one file. Okay, then we are calling this function f. Here in this function, we mention that it's external variable A. Here we did not define the variable again. We use the same variable. Okay, external variable A, where is it? Is it here? No. Where? It's here. Then it will take the variable from here. Then external variable A, this same A. Okay. Integer, then here we have declaration, integer B and C. This means we have two new variables. Of course, I forget to put C here. We have also C have initial value 3 and it's external also because it's outside all the functions here. Okay, we have a new B, which is local variable for the function f here. This B is local variable, and we have C also as a local variable. We mentioned that B equals C equal A, which A? This A equal A. Okay, A containing 1, then C now have 1 and B have 1 also. Return A plus B plus C, which is 3. Which A? This is a global A. Which B? Please turn off your mic. Because we have local B, we mentioned before that local variable mask or cover the global variable. Then, because we declare B and C as a local, then this one, the local one, not the global one. And this one, the local one. Let's have 1, 1, and 1, then the total 3. Okay, this print, then the control will return to the main function. This print will print A, B, C. Which A, which B, which C? Because we are here in this main function and we don't have local variable here in this function, then it will take the global, which have 1 and 2 for B and 3 for C. Let's try this one. Just A, E, and C, external A. Okay. Okay, first thing, it's print 3. Why? Because we mentioned here that B equals C equal A, and A, which is global one, have 1. Then C also will have 1 and B have 1. The summation will be 3. If you did not mention this keyword extern here, when you want to use this variable, if you did not mention extern, it will be compilation problem, compilation error. Okay, let me just show you. Error A undeclare. This one undeclare. You did not declare it. You did not give, for example, integer or extern to mention that it's external variable. Okay, then you can remove extern from the declaration, but you cannot remove extern here when you want to take this external variable from another file to use it. Then must be here. Now try. Okay, extern A. Another time. Let me. Okay. Extern integer. What's the problem? I think no problem. I don't know what's the issue. Okay. I should rebuild it again only. This issue. Okay. Then now it's working. Of course, after extern here, you don't need to mention the data type, integer, float, or something like this, because if you mention this, it's look like you are declaring a new variable, not the same variable. Okay. The difference here between auto and extern. Sorry, where is? Okay, the difference between auto. Oh. Let me use the. Okay, the difference between auto and extern. Okay, auto variable, you can use it inside the function like this B and C. Extern, you can use it in anywhere inside the file or other files like this file of your project or of your program. Okay, storage class or register class. Register class. Turn off your mic. Okay. In short or shortly, sometimes you need variable to or program part from the program to compile very fast. Actually, usually we do not use this except in limited situation. Why? Register a class. When you mention that this variable class is register, you are telling the compiler that you need to store this variable in registers of the CPU. It's high-speed memory and it's part from the CPU, but it's limited. The size is limited. Then it's simply that you are telling the compiler to store your variable in high-speed memory, which is registers that it's part from the CPU. This way allow you to have or to accelerate the program execution, but registers are limited. So you cannot use all variables or all your program to be or to use register, because usually programs and variables storing in the main memory. We call it RAM, yes. But also we have in the CPU small memory that used by the CPU called registers. It's part from the CPU. That's why it's very high speed. Okay, this example for using register. This example for using register variable. Here we have a loop. This loop running for 100 million times. It's not doing anything. When you have loop and after it you have semicolon like this means this loop not doing anything. Before this loop, we check the clock time for the CPU, and after it, we check the clock time for execution time, and we see the difference to know for how long this for loop running. Okay, that's why we use this library, this C library time. It's have functions like a clock to return the clock of the CPU, and it have some variable like a clock T. Here we define two types, two variables from this type, start time and end time. So when we define first a register integer I from type register. Then we print the starting time before the loop. Then we running the loop. Then we check the time after running the loop. We print in time after running the loop, and we also check the difference, the total time for running this loop. Calculating total time, it's end time minus start time, and we use this constant to convert this time to second. Okay. This constant, it's part from also this library to convert this time to second. Okay. Then we print the total. Let's run and see the difference between the speed of this execution for this for loop between if we have register variable or without using register variable. Register variable also it's local variable. Okay, then local variable could be auto or register. The different here where to store this variable. Okay, let's close this one. We have this one for register variable. Okay, let's run it. Okay, starting time 0, end time 55, and total time taken by CPU 0.055. Let's say 0.05. Okay, 0.05 using register. If we remove this keyword, then this become normal local variable, not register variable. Let's try again now to see the difference for runtime. Now runtime become 0.28. Oh, it's around 6 times, double 6 times the time. Okay, the running time. This is the difference between using register variable and the normal local variable. But actually, usually we don't use this except in some programs that have high priority and need to be run very fast and using for only small variables and few variables, not the whole program. Okay, another storage class which is static. Okay, I want you to put in your mind the variable, global variable. What the specification for global variable? You sometimes students mix between static and a global variable, but we will see the difference clearly here. We need to know the difference between static and the global variable. Actually, static keyword, you can use it, this storage class, for variables and also for functions. As I mentioned before, functions by default, it's a global. But you can mention that specific function, it's static. Here, it's different than global. We will see the difference here. So why we use static and what is a static declaration? Actually, we use static declaration for one of these two reasons. First reason, to retain or keep the value of the local variable. So usually we use static with the local variable to keep its value for next running for the block or for the function. I will clear it more. If you have local variable, for example, in this block, you have local variable integer a equal 3. Then if we imagine this the memory and then we have a and it's have value 3. What will happen when you reach the end of this block? It's normal local variable, or to be more clear, local variable usually it's an auto storage class. What's the meaning of auto storage class? This meaning if you define local variable inside the function, when you reach the end of the function, it will be automatically deallocated. Also, inside the block like this, when you reach the end of the block, it will be deallocated. This means it will be removed from the memory. Then, if, for example, there is something return you here from the beginning, then you need to allocate this variable another time with the new value. Even if you change the value here, for example, a plus plus, this increasing the value 1. Then next time you're using the function, for example, or the block, you will have the values from the beginning. Why? Because you removed the last value. This was the local, but if you mention that this variable is static, the situation will be different. What will happen? Like this, you will retain, you will keep the value of this variable for next use until the end of the program, not the block here. So if you have a program and you run program and you have static variable in part from the program, the memory will keep the value. Even if you change the value many times, it will keep the last value until the end of the program running. So if you mention that this one is static, integer, for example, the thing will be different here. Here you, for the first time, you declare it, you have the value, you change the value here, okay, for. If you return to this function or this block again, you reach the end, it will not be allocated from the memory. Why? Because it's static. Then if you need to run this function again, you will use a new value. No need to declare it again. You just declare it first time. So you retain, or in another word, keep its previous value when the block is re-entered again. Okay, this one use. Another use, and it's the most useful use for this static, to restrict the scope of external variable. If we return to this example, you see this external variable, you used it here in this file, in another file. But if you mention that this variable is static, this means you will restrict the scope to become only a global for this file that you declared the function inside it. You cannot use it if it's static outside the file from another file, even if it's in the same project. We will see examples. So another use is to restrict the scope to become global only for the current file that you define the function or the variable inside it. From another file, you cannot use here the static variable or function. So a global variable or function, if you put the static keyword before it, then you restrict the scope to be global only for the current file. You cannot use inside it, inside another file. Okay. Here, example for static. Okay. Another thing, if you have a static variable and you did not assign a value, the default value will be 0. Even if you did not assign value, the compiler will give initial value as 0. Okay, we have two examples. This example without a static variable and this example with static variable. Let's imagine we have this memory for running this program, and this another program. We have, for example, the memory here. Let's see the difference. It's same program exactly. We just have this local variable here without a static declaration, and here same variable with the static declaration. Okay, if we run the program here, we start from the main print function. This will call this function. In this function, we declare a local variable integer from type integer called count. Okay, we have this variable count with initial value 0. Then we make increment or incrementing this counter by 1. This means this value will change to 1. Then we return the value of count, which is 1. Then this will print 1. Then output will be 1. Print, we print same function again. But before that, when we reach return here, this is the end of the function. What will happen? At the first time running, we call the function, okay, count 0, then increase, then return. This function finished, end. What will happen now? Anyone focus with me? Okay, let me ask you. Okay, good. Good answer. We have someone with us here. Hammam, good. Deallocating. Why? Deallocating this variable. This variable, it's local variable. This means it's auto. Auto variable, when you reach the end of the function, will be deallocated or removed from the memory. Okay, then we don't have now count here in the memory. Now come to the next one, printf. We call this function again. Let me just remove for last run. and we are calling this function again. This function, we calling it again. Again, we have declaration integer count 0. There is no count 0 here now. There is no count variable in the memory, already de-allocated. Then another time, we have declaration for count 0, then count plus plus, which become 1, then return count 1, then we return 1, and we reach the end of the memory, then deallocated, printing this one. Then the next output will be 1. This the code without static. Now let's try same code. Instead of auto, now we have static local variable. Same thing, we call the function. This is another program. We finished this program. Now we have another program doing same thing, but we have static variable. Okay, we are calling this function static variable integer count. Then we have in the memory count, this local variable, but from the type static count, and initial value 0. Count plus plus, this means increment for count, it become 1. Return count, which will return 1. We reach the end of the function. What will happen now? What will happen with this variable count? We reach the end of the function that using this count. Then we have this variable count in the memory. What will happen for this variable? Okay, in the question in another way. Do the compiler will retain or keep this variable, or it will deallocate this variable? Okay. مش return, retain, this means keep. Okay, good. Then it will keep it. Okay, good. Good, Sultan. Al-Kazim, Sultan, and Hammam. It will retain it or keep it in the memory for the next run. And when we reach here, of course, we print 1. When we reach here, we call the function another time. This another run, when see this static declaration, it will check we still have count here or it's first time to use it. If it's first time, it will declare it. But if just already previously used, then it will check in the memory, okay, we have this variable count, no need to declare it again. Then now count plus plus, count already in the memory and have value 1. Plus plus, this means increasing it, incrementing it, then it become 2. Now return count, which is 2, then it will print 2. This is the difference between, yes, of course, static variable fix or keep or retain its value until what? Until the end of the program. This means when you reach the end of the main function, see in the program when you reach the end of the main function. Here, when you reach end of a program, it will be deallocated. Not before the end of program. Okay, here some students will ask, then what's the difference between this static variable and the global variable? Global variable also we keep the value. The difference here, the scope. The scope, the place that you can use this variable, and we will take, inshallah, a comprehensive example that have all these scopes to see the difference between this. The difference between a static variable here and the global variable, each variable have many things, have storage class where to store it and scope where you can use it. For example, in the whole program, only inside this file, or in inside a specific function, or even inside specific block. This we called it the scope. Also, we have something called lifetime for the variable. It will be available or alive for what time? A static variable and the global variable have the same file from the declaration until the end of the program running, but they are different with the scope. A static variable scope, it's inside the function or the block. Global variable inside the whole file. No, Sultan. Sultan, we are printing before incrementing, not after. Okay, we can run the program. I have the program here and you can check it. This thing, if you have the counter with the printing, but we are printing before incrementing. Oh, I understand your question, but for you mean for the first time? Let me show you here. Okay, seems I already changed this one. Let me without static and make it tick. Look, I understand what you are asking for. I will show you something. We are here incrementing, then return the value. What you mentioned that if we are incrementing inside returning here, this is a different. Okay, to make it much easier for you, if we close this one and incrementing here, then you are correct. But here we are incrementing before returning the value, not in the same sentence. This is a different. That's why you are confused. You understand it, Sultan? Sultan asking, because we are incrementing before the count, not after. And he said it should print 0, then 1. But the thing that you are missed here, okay, Sultan and the Abdu, the thing that both of you missed it, that we are incrementing before the return, before return here in separate sentence. Then it will be increment, then returns a value. It's different than if we make like this. If we increment here, this means, okay, return come before the increment. Then it will print 0, and after this, increment it. Okay? That's the different. Hopefully you understand the different, Sultan and Abdu. Then it will print 1 and 2. Is it clear, Abdu, Sultan? Or we don't have Sultan now around us? Oh, okay. Sorry, I did not see your comment. Okay. Static function. As I mentioned, functions by default global. By default global. This means if you have function, if you have 2 files in your project, and you have, for example, in this file, if function, of course, you have to include this file here. If you're using this file, in this file, if you have function, use it, it's okay, this is correct. Why? Because function by default is global. But if you mention like this before the function, the keyword is static, then you restrict the scope for this function to become only inside its file. Then this will not work here. If this function becomes static, this means you can use it inside its file. You cannot use it outside its declaration file. You cannot access it from outside. This difference between non-static functions, because it's global by default, and the static functions. Okay, then let's make it more clear for static variables, because some students confuse between a static variable and a global variable, static local variable and local or auto-local variable. To make it clear, what's the difference between a static and the global variable? Both have the same lifetime. Global variable lifetime until the end of the, and the static variable lifetime will be until the end of the program life, for how long it will stay in the memory. It will stay in the memory when you declare it until the end of the program running. Both have the same lifetime. The main difference will be the scope. Scope means the place that you can use this variable inside. Okay, the scope for the global variable will be the whole program, and if it's a static global variable will be the whole file. But the scope for the static variable will be the function or the block that you define this static variable inside it. Then if you declare this static variable inside functions, then the scope will be this function. If it's inside a block, not the whole function, then the scope or the place that you can use this variable will be inside this block. Of course, the global variable, you declare it outside all the functions, and the scope for it will be the whole program, and the life will be until the end of the program. It can be accessed from outside the file or the program file if it's a global or external variable. Okay, static variable, it's limited to the source file. Okay, the files that you define the variable inside it, and it's not accessible from other files. Sorry, here we compare between a global variable and the static variable in generally, maybe global static or local static. So it will be available for function block if it's local static, and for the whole file, only one file that you declare it if it's a global static, a global. Okay, what's the difference between static local and static global? Also, again, they have the same lifetime. But the difference also in the scope. Static local inside function or block. Static global inside the whole file. Could be in many functions, you can use it, but you cannot use it outside this file. For example, if you have 2 or 3 files in your project and you have a static global variable here, you cannot use it inside another file. This comparison will gather all this idea. We have 4 storage class: auto, register, extern, and static. Static, we have 2 types from static: static local and static global. Let's see the difference. In some types, in some things or terms, they are similar. In some terms, they are different. For example, for the declaration for auto and register will be similar inside the function or block. Declaration for also static local, similar to auto and register, will be inside function and a block. Declaration for external variable or static global variable will be outside all the functions. Then if you have a file here and you have many functions, outside all the functions you can declare the external variable and the static global variable. What about the storage? Where to store everyone from these types of variable? Look, auto variable will be stored in the stack. What another type of variables that will be stored in the stack? If you remember, we mentioned before that parameter variable for functions and local variable, which is auto by default, will be stored in some part from the memory that called the stack. We will see the stack and how it works, inshallah, during this class later. Okay. Register will start in CPU register. External and static, even if it's local or global static, all this type will be stored in the data segment. C usually divides the memory into parts. Some parts called data segment, and we have text segment, and we have heap segment, and we have also stack segment. We will see each one and what exactly is. Then external, static, local, and static global will be in data segment, will start in data segment. What about the default initial value? This means if you define variable like this, integer a, and you did not give initial value, what will happen? Look, for auto and register variable, you will the compiler will book the part from the memory needed for the auto in the stack, for register variable in the register of the CPU. But you did not mention here the initial value. Then what value will be inside the variable? To understand it, let me have, for example, okay, I will open as paint. To understand this issue, it's like this. If we imagine this is the memory. Okay. For example, let's say you are running one of your games. You are playing, for example, PUBG or any game, or you are opening the browser, or like this, we are opening MS Paint. What will happen in the operating system? Operating system will bring this program into the memory. Then you will book some parts from the memory for each running program. Let's say we have this address in the memory. Sorry, we usually use this this one for memory address. Oh, cannot draw it. Okay. For example, you have this one xf00 as address for this part from the memory. You use many programs, then each program will be stored in the memory. For example, here 0, here 1, 2, 8, blah, 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 blah. Okay. When you stop running this program, the operating system will deallocate the programs, not actually deleted it from the memory. That's why, if you remember, when we speak about auto register, we said deallocated. What's the meaning of deallocated? Just remove the pointer. This what happened. This pointer not pointing to this part from the memory. Then next time you're running anything, the operating system will tell you that this part from the memory empty, but it's not actually empty. It have data from another programs or another game, okay, for example, but it's not the value that you need. So when you define variable like this without initial value, then the compiler need to book part from the memory. Then it will ask the operating system, where's the empty place? Operating system, for example, will tell you this empty place. Then you will use this place for your variable A, for example. But it have already value from another program. That's why we called it garbage. It's garbage for you. It's not the value that you are need. Okay, then if you did not declare the auto or did not give initial value for auto variable or register variable, you will have garbage initial value. Then later when you, for example, assign value, this garbage value will change for the new value. This thing different here for external, static, local, and static global. If you did not give initial value, the compiler will give 0 as initial value. By default, the compiler itself will give 0. So this integer, if it's static, then its initial value will be 0 if you did not mention the initial value. If you do not believe me, then you can try to print any thing. For example, okay, let's print any variable here. I want to define variable integer A, then print A. Try this one. Okay. Okay, I have one more practice here. Okay, we have 0 as garbage value. I did not give it as initial value. Let's try another variable, for example, x. Most values will be 0, but sometimes you will have a garbage value different than 0. For example, we have here 16. Then when you declare this variable x, then the compiler give address in the memory. This address already contains 16 from value 16 from a previous program running. Not our program, maybe any program from the operating system. Okay, we will finish this one, then we can take a break. Okay. About the scope, you see here the lifetime and the scope. A scope means the place that you can use this variable. Lifetime, this means for how long this variable will be available to be used. Okay. For example, for auto, the scope will be the function and the block. And the lifetime will be the function and the block. This means if the function finished or the block finished in, it will be automatically deallocated from the memory. If you want to use the function another time or the block another time, then the auto variable will be declared from the beginning another time. Registers have same scope and same lifetime. Then what's the difference between auto and register? The only difference where to store this variable. Okay, about the external variable scope will be entire the program, entire file and other files of your program. Not only one file, all the files of your program you can use the external variable, but you need to mention in each file you want to use it that it's extern. You have to use the keyword extern to use it from another file. Then it's the biggest scope here, all the files of your program. And what about the lifetime? Lifetime program runtime. When you declare it in the program time, in the running of the program, then it will be deallocated. Static global and static local have same lifetime, the whole program runtime. But the difference between static local and static global will be the scope. Here you see the scope of the static local will be the function and the block. Then you can use it many times. Each time you run the same function that you declare it, inside the function. But you cannot use it outside this function or outside this block. Static global, it's a global. You can use it for entire file only. Then if you want the difference between extern and static global, here's the difference. Extern can be used in many files, all the files of your program. But static global, it's a global inside the file that you declare it. I mean, if you have 2 files, 3 files, 5 files, you declare here static global, then you can use it only inside this file. You cannot use it inside another file of your program. This is a comparison between the storage classes. After the break, inshallah, we will take this scoping example to see the difference of running between each one. Can we use normal global in multiple files? Already I mentioned normally global. This extern is the normally global. You can use it in many files, but you need to use this keyword extern in each file. Okay, understand me, Sultan? external variable, it's the normal global variable. But if you, let me return to this program. Okay, main and file2. Okay. This variable, it's a global. Even if you did not use a extend keyword here, it's okay. It will run. We have already running here, yes. Even if you did not use the keyword extend, it's a global variable. Then you can use it here. But to use it in another file, we have two files here, you need to use this keyword extend. Then okay, then as you can see here, it's okay. We use this variable here, a here. But if you did not use extern keyword, it's the global variable here, you will have a problem. That's the issue. That's all. We have a break now for 10 minutes. We return, inshallah, at 2 and 10 minutes or 14:10. Okay, and then break till 14:10. This means around 10 minutes from now. See you after 10 minutes. Break. Okay, assalamu alaikum again. How many students around? Please raise your hand if you are around. Okay, then we'll continue our class. This example to show you the different scoping and also lifetime. So during this example, we will see the difference between each type of variable, scoping and lifetime. We will actually the problem we don't have enough space here, so I try to make it clear. We will use this part as the memory, and we will use this part for output. It's hardly enough. Okay. Okay, we start our program here. We have three functions: declaration, use local, use static local, and use global, just any name for the functions. And here we are starting integer x equal 1. What's the type of this variable? It's a global variable, or in another term, it's external variable. Okay, global variable or external variable. Without mention the keyword extern, it's a global variable. Okay, then we define variable x as a global and we give initial value 1. Then we have this variable x with initial value 1 and its type is global variable. Okay, then we start the main function here. And we have declaration for x another time, integer x equal 5. This integer x, it's different than this one. It's not the same. This local, then we declare a new variable with the same name. And we mentioned before that you can declare many variables with the same name, but not inside the same block. Then this x is a new variable, then it will take another part from the memory. This x have initial value 5. And this variable is local variable for main function. Actually, its scope will be from the beginning of the main function until the end of the main function. Okay. Then we have printing here. Then we have output. print local x in outer scope of main blah 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 blah. I will not print all this. I just will print the value of x. What is the value of x here? To know the value of x, okay, good. It's 5, yes. To know the value of x, you need to know this one, which x? Actually, we mentioned before that local variable mask or cover the external or the global variable. Then this one is the local variable x, not the global, not the global. It's the local. Why? Because local variable cover or mask the global variable. What do you mean? Which class? We are inside our class. Already started more than one hour. Okay. Oh, our class still running. Okay. You confused me actually. Okay. Then this one is a local variable x, and it's half 5. Then this will print this sentence, local x in outer scope of main blah blah blah. Then this place for this variable x. We will print only the variable value, which is x equal 5. This will print 5. Okay. Continue. We start a new scope. You see here, we start a new block, a new scope. And inside this, you can ask this question using Telegram. Our class usually start 12:40. And it will end 14:55. Anyway, any discussion, please make it on Telegram group. I can mention anything for you, and if you don't know anything, I will describe it for you. Okay? We start a new scope here, a new block. This block have a new declaration for x. Actually, this x different than also this x. However, this one local and this one local. This one local for the main function, for the whole main function. But this one local for this block. Also local for the block will mask or cover local of the function itself. So It's have here the highest priority inside the block. Then we have a new X variable with initial value 7. This one local main, but this one outer, and this one inner. Okay. Please don't chat here during the course. We have Telegram group. If you have any question, if anyone have a question, answer him on Telegram group. Don't answer each other inside our class, okay? Just ignore, Abdu, ignore. Okay. We have here another printing statement. Local X in the inner scope and printing X. This one, which X? It's the local inner because it's inside this block. Then it will print the value of the local main inner, which is 7. Then we reach the end of this block. I need one from you. Tell me what will happen for this variable X. This one. We reach the end of this block. Then what will happen for this X? It will be deallocated. Yes, correct. Why? Because we reach the end of the block that we declare it inside. Then, because it's local and we reach the end of the block, then it will be deallocated. Okay, continue. Print if X, what X this one? It's inside the name is a main. This mean it's the local one here of the main. Okay, good. It will print 5 because it's the local for the main, local outer. So we have 5 here in the local main outer, then we will print 5. Okay. Now we start the magic. Use local. Use local is a function. We are calling this function use local. Inside use local, we declare a new X variable, which is local for this function. Then we have a new X here with initial value 25. And this X is local for use local function. Okay, print X. This x, which one? It's the local, because it's inside this function. We have local. If you have local variable, then it will cover or mask the global variable. Then it's the local variable which is have 25. Then we are printing 25. Now x plus plus, this means we increase the value of x. Then it's become not 25, now 26, because we make increment here. Then we print x again. Which x? Also local x, but it have a new value here. It have 26. Then it just will print 26. Okay, good. Now we reach the end of the function. What will happen? Good. We will deallocate this local variable. Then we deallocate this variable again. It's better to clear some parts from the screen. I will remove this part because already deallocated. Okay. Okay. We reached the end of the function. We deallocated this variable and the control return here for the main function. In the main function, we calling a new function, use static local. We calling this function. Inside this function, we declare a new variable, which is static integer x. Then we have a new variable x. Okay, I will give more space for it. We have a new variable x, which is static local variable, and we give value 50. Then now print if x. Of course, this printing inside this function, this means the compiler will look first to any local variable. We have local variable. This one, static local variable. Then it will print the 50 from the memory here. Then increasing x. Then x will become 51. Print x again. It's the same variable, but with the new value, which is 51. Then we reach the end of the function. What will happen now? Or in another way, this variable x, it will keep or remain in the memory, or it will deallocated. The answer here, because it's a static variable, it will stay in the memory. Even if we reach here the end of the function, okay, we reach the end of the function, but it will stay with the new value in the memory here. Okay, good. Then the control will go to the main function which will call this function. Use a global, sorry. Just the space is very tiny space, small space. We reach here, use global. Okay, for use global, this is the starting, print fx. This x, which x? Because we don't have, yes, Abdu, correct. Because we don't have any declaration inside this function, then the compiler will look for this x in the global. Do we have a global variable with the name x? Yes, we have this variable. Then this function will use this global variable because it do not have local variable. Then this x, it's the global x. Global x. And the value in the memory for the global x is 1. Okay. Then now, here, x multiplied by 10. This means x, a new value for x, equals the old value of x multiplied by 10. And give the result, or put the result inside x. Old x1 multiplied by 10, then it will equal 10. Now inside x here, the global x, the new value will be 10. Print x again, which is also the global x. Now look inside the memory, the new value 10. Then it will print 10. Okay, good. We reach the end. Of course, this global variable, then it will not be deallocated when we reach the end of the function. Return to the main function, use local. Use local. This function, I will just clear this. Okay, good. Then use local, which is this function. Another time, we declare a new local variable x. Then x, another time. We used it before, but we did not keep the value in the memory. Why? Because this auto, this local variable, not the static variable, then the all values are removed from the memory. Then we have this as a local variable for this function, use local, and from the beginning it's 25, then print it, x plus plus, then 25 become 26, then print x again, we print 26. We reach the end of the function. This means we will deallocate x again. And the control become here. Use static local. Another time static local. Okay, here the question. Okay. We have this static declaration. Now the compiler will do this. When we have static, it will look to the name of the variable. Do we have this static variable in the memory? Yes. Then it will not give the initial value again. It already have value. It will not give a new initial value. Then this is the difference between declaration without static and static. Without static, every time the initial value again and do everything again. Herefore, it will not use the initial value if it's already exists. It will use the existing value. Here is 51. Then, when it will print this X, it will look to the memory for the static and it will find it 51. Then increase X, it become 52. Then print this static X again, it have 52, it will print 52. Okay, we reach the end of the static local function. Also, this static local variable will stay in the memory. Now the control return to the main function and it will call the function use global again, this function. Okay. Again, this function do not have any declaration for X. So when I want to print X, no declaration inside the function. This means it's a global X. Then the compiler will go to the memory. Okay, this global X have value 10. Then it will print 10. Now, X equal old X multiplied by 10. Old X in the memory here, the global X have 10. Then it's mean 10 multiplied by 10, which equal 100. Sorry. Okay, 100. Then in the memory, this become 100, the new value. Print X, then which X? It's the global X, same X, which have 100 value. Now the control return here to the main memory, main function, sorry, print F, which have X value. Which X? This one, good. It's 5, yes. Which X? It's the local X. Sorry, not this local X, this one. It's the local X for the main function. If you have local X, then it will mask or cover the global variable. If you have local variable, then it will print 5. Then return 0. This means the end of the function. Now, when you finish the runtime here, the runtime for your program, now and only now, all the static and the global variable will be deallocated from the memory. Okay, that's all for this program. And this values, as we mentioned, 5, 7, 5, 25, 26. Okay, same values when we tracing this program. This is output for the program. Output have a lot of printing, but because we don't have space, we print only the numbers here. Okay, we continue with a small subject from another slide. Which one? I think this one. Actually, we late little bit, so we will speak about the memory layout. Give a look for memory layout. Okay. In this slides or lecture note, we have 3 subjects: memory layout of C, what type of memory, and we mean when we speak about the storage class, we saw that we have many types of or parts from the memory that C using it. So we will know the difference between each memory layout. Then after that, not this week, maybe next week, we will speak about generating random numbers and recursion or recursive functions. Okay. About memory layout, we still have 15 minutes. Inshallah, we will finish on time. Just if we reach the time, remind me if you have a class also. For C, a typical memory that used by C consists of 5 parts or sections or segment. Okay, then C using or dividing the memory into 5 segments. First segment, which is text segment, it's called binary code segment or containing binary code segment, or in another term, it's containing the executed program itself, your compiled program. Even the compiler itself will, the instance of the compiler will be inside this one, the programs. About the data segment, we have 2 types of data segment. Then data segment, we have 2 types of data segment. We have initialized data segment and uninitialized data segment. Uninitialized data segment, they give it a short BSS, and initialized data segment DS. DS data segment and BSS uninitialized data segment. Okay, then if you have a variable with declaration and initial value will be stored in initialized data segment. If no initial value, then it will be stored in uninitialized data segment. Also, we have another part which called heap. Heap, this used with some objects or declaration in C that can be changed. The size of it, dynamic, can be changed. Not dynamic means here auto. Dynamic different than auto. Dynamic here means it can be changed. The size of this object can be changed during the runtime. Like array. Okay. Array and and linked list array and linked list. Later we will use array and we will use linked list also during this course. It's not the time to define them. They are objects or structures in C that can, the size of it can be increased or decreased during the runtime. This type of declaration will start in heap. That's why heap memory or this part can be increased or decreased. It moves towards up like this or decreased. This moving. If you store more data, it will increase toward the stack. Last part is the stack. The stack will be used for the functions. Each time you run the function, you will have something we call function instance. Okay, or a copy from this function to define the return value of the function and to define the passing parameter of the function and define the variable of the function. All this data will be stored inside the stack. And the stack can be increased also towards the heap. Then heap growing towards the stack and the stack growing towards the heap. You have part empty between the stack and heap to give the opportunity for the heap and the stack to growing toward each other. Okay, then we have text segment. We will now speak about these 5 types of the memory represented or section of the memory, segment of the memory that used by C program. First one, text segment or code segment. Sometimes we call it code segment. It's for the object file. When you compile any program by compiler, it will convert it from source program or source file to object file. This object file will store in the text segment. Okay, then as I mentioned, the object file, it's the compiled version from your source, then it's executable instruction. Okay, this part is shareable by more than one program. That's why you have usually single copy from programs that you executed many times frequently, like the C compiler, the editor of the C language, the shell, and so on. This parts, editor, I mean IDE that you're writing the code inside, and C compiler and the shell of the compiler. Shell, it's come from operating system, this term. It's not our job to describe it now. All this type of program will be stored in text segment. Okay, and it's read only, because after you have the executable file, you don't need to change it. So it's read only to prevent any problem inside the program or any changes. So imagine you start your program here and it's not readable only. Then another program come and start over your program. Then you will have a problem. So to prevent this, accident, it's read only. This means when you start in this part from in the memory, you cannot change it during the runtime, I mean. Okay, about the data segment, we have two types of data segment. Initialized data segment, and shortly we name it DS, and uninitialized data segment, they called it BSS. It's come from the word block started by symbol. You don't need to memorize this block started by symbol, but to know it come from where, I mentioned it for you. Then uninitialized data segment, or shortly we name it BSS, and initialized data segment. From its name, initialized data segment, if you define a global variable or static variable and you give initial value, it will stored in DS, in initialized data segment, like this. If you have a file and outside all the programs you define integer x equals 0, then this is global because it's outside all the function and have initial value, for example 1 or 2 or any initial value, then it will stored in DS, data segment. Also static variable. Static variable could be inside function, but the static, if you mention that it's a static variable and give initial value for it, also it will be stored in initialized data segment. For uninitialized data segment, same variable, global variable or static variable. If you did not give initial value, then the compiler or the kernel will give 0 as initial variable, but it will be stored in uninitialized data segment. Then same variable here. If you did not give initial value and it's a global like this, it will be stored in uninitialized data segment and it will give in a 0 value as initial value. Then it's contain all global variable and static variable that uninitialized, so it's initialized by 0 from the compiler. Okay, stack. There is no time to speak about stack today, so we stop here and we continue inshallah next week to speak about the stack, heap, and random numbers and recursive function, inshallah. So that's all for today. Okay, here. Okay, that's all for today. Thank you for attending the class. See you inshallah next week inshallah. And Assalamu alaikum. Guru Shuruz.